my dear students. In the previous videos, we discussed determinant properties of determinants. In that, the four properties I discussed, and today's class I am going to discuss the fifth property. So, what it says? The fifth property says, my dear students, here, if some or all elements of a row or column of a determinant are expressed as sum of two or more terms, then the determinant can be expressed as sum of two or more determinants. So it means I'll take one example so that clearly you can understand, my dear students. For example, I'll take one example. So what it says here is, in this example I am considering the determinant here, it is a1 plus lambda 1, a2 plus lambda 2, and here it is I require some space, so therefore better I write here. So here it is a1 plus lambda 1, a2 plus lambda 2, a3 plus lambda 3. Clear? So my dear students, here the first row I expressed a1 plus delta 1. It means that here it is the a1, to the a1 element I added another one term. So it means that for if you observe the first row elements, these are the sum of the two terms. Here it is a1 plus lambda 1, a2 plus lambda 2, a3 plus lambda 3. Like this, sum of the two terms is there. And now remaining elements I am taking it as b1, b2, b3, c1, c2, c3. Clear? So this can be expressed as a1, a2, a3, b1, b2, b3, c1, c2, c3 plus, and now here it is the remaining elements I can write it as lambda 1, lambda 2, lambda 3, and next remaining elements are that b1, b2, b3, c1, c2, c3. Clear? So my dear students, and now you can understand. So if some or all elements of a row or column of a determinant, this is the one determinant I have. So in this determinant, if some or all elements of a row or a column, it may be the rows or it may be the columns, so are expressed as a column of a determinant. This is the one determinant. In this determinant, in this particular example, to the first row, all the elements of the first row are sum of the two terms. It may be the two terms or it may be the more terms. But as of now, I took the example. Here in the first row, we have the two terms. Sum of the two terms is there. Clear? Then this determinant can be expressed as sum of two terms, sum of two or more terms. Here I have in the first row sum of the two terms. In the first row the elements are sum of the two terms is there. So this determinant can be expressed as sum of two determinants. So that is what our statement here is, sum of the two or more determinants. This is the one determinant I have. In this determinant, in the first row the elements are sum of the two terms is there, a1 plus lambda 1, a2 plus lambda 2, a3 plus lambda 3. It means that two terms are there. Clear? So this determinant can be expressed as, we can separate the terms. Here it is a1, a2, a3, a1, a2, a3 first I wrote, and remaining b1, b2, b3 as it is, c1, c2, c3, c1, c2, c3 as it is. Plus, now I can add this lambda 1, lambda 2, lambda 3, lambda 1, lambda 2, lambda 3, and remaining elements as it is, b1, b2, b3, c1, c2, c3. So therefore, whenever you have the determinant, in the determinant, either in the row or in the column, sum or all terms expressed as the sum of the two terms or more than two terms, in that case, that determinant can be expressed as sum of the two determinants. Clear? Two or more determinants. So this is the one example I taken here is, so that you can easily identify. Clear? Now I will solve this one, my dear students. So to solve this one, what I will do, I will consider LHS part. So this part I will consider. So what is LHS part here? It is LHS is here This is I can take it as LHS, and this part I can take it as RHS. LHS means left hand side and this is RHS means right hand side. Now I will consider the LHS left hand side and then I will prove the RHS. So now consider LHS. So I will consider the LHS. So this is your LHS. I will write the ones as it is. A1 plus lambda 1, A2 plus lambda 2, A3 plus lambda 3. Clear? B1, B2, B3, C1, C2, C3. Clear? So this is the one determinant I have. Now, my dear students, I will solve this determinant, and already we know how to solve the determinant of the order 3. So first we should put the sign plus minus plus. Now simplify this, my dear students, further. If you simplify this, plus into this element into this element, plus a1 plus lambda 1 plus a1 plus lambda 1 into leave this row and this column, remaining elements b2c3 minus of c2b3 next minus of this element, minus of, here it is, a2 plus lambda 2 into, here leave this column and this row, b1c3 minus of, here it is b1c3 minus of c1b3 plus of this element a3 plus lambda 3. Again here it is, leave this row and this column. Now b1c2 minus of c1b2 I am leaving, here it is, this row and this column, b1c2, here it is, minus of c1b2, like this. Clear? Now my dear students, a1 plus lambda 1 is there, so multiply once to this term with a1 and another time multiply with lambda 1. Clear? So first what I do, I multiply a1 with this to this term, a2 with this term, a3 with this term, and next I will write lambda 1 into this term, minus of lambda 2 into this term, lambda 3 into this term. Clear? So therefore here it is, a1 into all these elements I am multiplying, b2c3 minus c2b3. Clear? And next minus of a2 into this b1c3 minus c1b3. Clear? And next my students, plus of, here it is, plus of a3 into these elements, b1c2 minus c1b2. Just I will check whether it is visible to you or not. Yes, it's visible to you. So now my students, further I can write a1 into this term, minus of a2 into this term, and next plus a3 into this term, Now plus of lambda 1 into again this term. So what is that? b2c3 c2b3. Next plus minus lambda 2 into this term, b1c3 c1b3. Clear? And next my students, plus lambda 3 into this term, again b1c2 minus of c1b2. Clear? And now my dear students, you can observe, or you already know that this I can write, here it is, this term I can write it as, can I write it as determinant of a1, a2, a3, b1, b2, b3, c1, c2, c3. My dear students, if you expand this, again you will get this term. So therefore, this entire term I can write in the form of determinant like this. You can also verify that if I solve this determinant, whenever you will get that or not, we will check. Clear? So after solving this, you will get this or not, I will verify it now. So plus here it is, again you should change the sign, plus into a1 into, leave this row and this column, b2c3 minus of c2b3. I got it. Next, to this minus a2 into, just I am checking if I solve this determinant whether I am getting this or not. That I am checking, my dear students. Now minus a2 into, leave this row and this column, b1 c3 minus of c1 b3 I have. Next plus a3 into, again leave this row and this column, b1 c2 minus of c1 b2, again that I have. So therefore this entire I can write the determinant like this. Clear? And similarly, my dear students, this also can be written as, here plus sign is there, so plus, here it is plus, this entire again I can write it as, you can observe here it is lambda 1, lambda 2, lambda 3. Next b1, b2, b3, c1, c2, c3. Clear? So you can again verify after solving this determinant, you will get this only. I'll verify just lambda 1 into plus lambda 1 into, leave this column and this row, b2 c3 minus c2 b3 I got. And next minus of lambda 2 into, leave this row and this column, so b1 c3 minus c1 b3. Next plus lambda 3 into, leave this row and this column, b1 c2 minus c1 b2. Clear? So therefore this entire can in the form of determinant I can write like this, and this entire I can write like this. Clear? So therefore this is what your required RHS. So this is your required RHS. I hope you understood. So therefore whenever you have the determinant like this in the row or in the column, if some or all elements of a row are sum of the two terms, then that determinant can be written as sum of the two determinants, or if the terms are more, then you can write sum of the two or more terms you can write. Clear? So this is the property number 5th. So very important properties these all are. So still if you have any doubts, you can comment me, I will reply for that. Clear? And now my dear students, I will once just briefly explain in Kannada. So ನೋಡಿ ಏನು ಹೇಳಿದ್ರೆ ಕನ್ನಡದಲ್ಲಿ ಅಂತ ಹೇಳಿದ್ರೆ, if sum or all elements of a row or column of a determinant are expressed as sum of two or more terms. ಸೊ ಏನು ಹೇಳಿದ್ರೆ ಕೆಲವು ಸಮ್ ಅಂದ್ರೆ ಕೆಲವು, ಸೊ ಯಾವುದೇ ಕೆಲವು ಟರ್ಮ್ಸ್ ಅಥವಾ ಎಲ್ಲಾ ಟರ್ಮ್ಸ್ ಎಲ್ಲಾ ಎಲಿಮೆಂಟ್ಸ್ ಯಾವುದೇ ಡಿಟರ್ಮಿನೆಂಟ್ ಇದು ರೋ ಆಗಿರಲಿ ಅಥವಾ ಕಾಲಮ್ ಆಗಿರಲಿ, ರೋ ಅಥವಾ ಕಾಲಮ್ಸ್ ಅಲ್ಲಿ ಯಾವುದಾದ್ರೂ ಎಲಿಮೆಂಟ್ ಅಥವಾ ಎಲ್ಲಾ ಎಲಿಮೆಂಟ್ಸ್ ಏನಾದ್ರೂ ಎರಡು ಟರ್ಮ್ ಅಥವಾ ಮೋರ್ ದನ್ ಎರಡು ಟರ್ಮ್ ಬರೆದಿದ್ದಿತ್ತಂದ್ರೆ ಸೊ ಡಿಟರ್ಮಿನೆಂಟ್ ಅಲ್ಲಿ, ಸೊ ಆ ಡಿಟರ್ಮಿನೆಂಟ್ ಅನ್ನು ಹೇಗೆ ಎಕ್ಸ್ಪ್ರೆಸ್ ಮಾಡಬಹುದು, ಸಮ್ ಆಫ್ ದ ಟೂ ಟರ್ಮ್ಸ್ ಆರ್ ಮೋರ್ ದನ್ ಟೂ ಟರ್ಮ್ಸ್. ಸೊ ಇಲ್ಲಿ ಈ ರೀತಿ ಬರೀಬಹುದು ಅಂತ ಹೇಳಿ ಪ್ರಾಪರ್ಟಿ ಹೇಳ್ತೇವೆ. ಸೊ ಇಲ್ಲಿ ಎಕ್ಸಾಂಪಲ್ ತಗೊಂಡಿದ್ದೇನೆ. ಈ ಎಕ್ಸಾಂಪಲ್ ಏನ್ ಮಾಡಿದ್ದೇನೆ, ಫಸ್ಟ್ ರೋ ದಲ್ಲಿ ನೀವು ನೋಡಬಹುದು ಎಲಿಮೆಂಟ್ಸ್ ಎಲ್ಲ ಹೇಗಿದಾವ, a1 plus lambda 1, ಸಮ್ ಆಫ್ ದ ಟೂ ಟರ್ಮ್ಸ್ ಇದಾವೆ. a1 ಅನ್ನೋದು ಒಂದು ಟರ್ಮ್, lambda 1 ಅನ್ನೋದು ಒಂದು ಟರ್ಮ್. ಸೊ a1 plus lambda 1, a2 plus lambda 2, a3 plus lambda 3. ಸೊ ಈ ರೀತಿ ಯಾವುದೇ ಡಿಟರ್ಮಿನೆಂಟ್ ಅಲ್ಲಿ ನಮಗೆ ಏನು ಹೇಳಿದಾರೆ, ಇಲ್ಲಿ ಯಾವುದೇ ರೋ ಅಥವಾ ಕಾಲಮ್ ಅಲ್ಲಿ ಸಮ್ ಆಫ್ ದ ಟೂ ಟರ್ಮ್ಸ್ ಇದ್ರೆ ಆ ಡಿಟರ್ಮಿನೆಂಟ್ ಅನ್ನು ಹೆಂಗ್ ಬರೀಬಹುದು, ಸಮ್ ಆಫ್ ದ ಟೂ ಆರ್ ಮೋರ್ ಟರ್ಮ್ಸ್ ಅಂತ ಬರೀಬಹುದು ಅಂತ ಹೇಳಿದ್ರು. ಸೊ ಈ ಎಕ್ಸಾಂಪಲ್ ಅಲ್ಲಿ ನೋಡಬಹುದು ಫಸ್ಟ್ ರೋ ದಲ್ಲಿ ಸಮ್ ಆಫ್ ದ ಟೂ ಟರ್ಮ್ಸ್ ಎರಡು ಟರ್ಮ್ ಅದಾವ, ಪ್ರತಿ ಎಲಿಮೆಂಟ್ ಅಲ್ಲೂ ಎರಡು ಟರ್ಮ್ ಇರೋದ್ರಿಂದ ಈ ಡಿಟರ್ಮಿನೆಂಟ್ ಅನ್ನು ಹೆಂಗ್ ಬರೀಬಹುದು, ಎರಡು ಟರ್ಮ್ ಎರಡು ಡಿಟರ್ಮಿನೆಂಟ್ ಆಗಿ ಬರೆದಿದ್ದೇನೆ. ಈ ರೀತಿ ಬರೀಬಹುದು ಅಂತ ಹೇಳಿ ನಮ್ಮ ಪ್ರಾಪರ್ಟಿ ನಂಬರ್ 5 ಹೇಳ್ತದೆ. ಸೊ ಇದನ್ನ ಪ್ರೂವ್ ಮಾಡ್ಲಿಕ್ಕೆ ನಾನು ಏನ್ ಮಾಡೀನಿ, LHS ಅಂತ ಹೇಳಿ ಇದನ್ನೆಲ್ಲ ತಗೊಂಡಿದ್ದೆ. ಸೊ ಇದನ್ನ ಸಾಲ್ವ್ ಮಾಡಿದೆ, ನಿಮಗೆ ಸಾಲ್ವ್ ಮಾಡಿ ಬಂದಾಗ ಏನು ಸಿಕ್ಕಿದೆ ನನಗೆ ಈ ರೀತಿ ಬರೀಬಹುದು ಅಂತ ಗೊತ್ತಾಯ್ತು. ಅದಕ್ಕೆ LHS is equals to RHS, either or else you can write here it is, therefore LHS is equals to RHS. Clear? So like this you can prove this result. ಆಮೇಲೆ ಅದನ್ನೇ ನಾನು ಏನು ಮಾಡಿದೆ, LHS ಅನ್ನು ತಗೊಂಡೆ. LHS ಅನ್ನು ತಗೊಂಡು ಈ ರೀತಿ ಡಿಟರ್ಮಿನೆಂಟ್ 3x3 ಇದ್ದಾಗ ಹೇಗೆ ಸಾಲ್ವ್ ಮಾಡಬೇಕಂತ ನಾನು ಆಲ್ರೆಡಿ ಹೇಳಿದ್ದೇನೆ. ಸೊ ಹೇಗೆ ಸಾಲ್ವ್ ಮಾಡ್ತೀವಿ, ಫಸ್ಟ್ ಯು ಶುಡ್ ನಾವು ಫಸ್ಟ್ ಸೈನ್ ಅನ್ನು ಬರೀತೇವೆ, ಪ್ಲಸ್ ಮೈನಸ್ ಪ್ಲಸ್ ಪ್ಲಸ್ ಇಂಟು ಈ ಎಲಿಮೆಂಟ್ ಅನ್ನ ಜೊತೆಗೆ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಬೇಕು. ಯಾವ ಎಲಿಮೆಂಟ್ ಜೊತೆ, ಈ ರೋ ಮತ್ತೆ ಈ ಕಾಲಮ್ ಅನ್ನು ಬಿಟ್ಟು ಇವೆರಡಕ್ಕೂ ಡಿಟರ್ಮಿನೆಂಟ್ ವ್ಯಾಲ್ಯೂ ಜೊತೆ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡ್ತೇನೆ. ಸೊ ದಟ್ ಅದನ್ನ ಈ ರೀತಿ ಸಾಲ್ವ್ ಮಾಡಿದ್ದೇನೆ. ಸೊ ಇದನ್ನ ಸಾಲ್ವ್ ಮಾಡಿದಾಗ ಇಲ್ಲಿ a1 plus lambda 1 ಇಷ್ಟು ವ್ಯಾಲ್ಯೂ ಸಿಕ್ತು. ಇಷ್ಟು ವ್ಯಾಲ್ಯೂಸ್ ಅಲ್ಲಿ ನಾನು ಏನು ಚೆಕ್ ಮಾಡ್ತೀನಿ, ಫಸ್ಟ್ a1 ಇಂಟು ಈ ಟರ್ಮ್ ಬರ್ದೇನೆ, ಮೈನಸ್ a2 ಇಂಟು ಈ ಟರ್ಮ್, a3 ಇಂಟು ಈ ಟರ್ಮ್ ಬರ್ದೆ. ನೆಕ್ಸ್ಟ್ lambda 1 ಇಂಟು ದಿಸ್ ಟರ್ಮ್, lambda 2 ಇಂಟು ದಿಸ್ ಟರ್ಮ್, lambda 3 ಇಂಟು ದಿಸ್ ಟರ್ಮ್ ಬರ್ದಿದ್ದೇನೆ. ಕ್ಲಿಯರ್? ಅಂಡ್ ನೆಕ್ಸ್ಟ್ ಇದನ್ನೆಲ್ಲಾನು ಏನು ಬರೀಬಹುದು, ಸೊ ಇದನ್ನ ಡಿಟರ್ಮಿನೆಂಟ್ ಆಫ್ a1 into a3 b1 into b3 c1 c2 c3 ಈ ರೀತಿ ಬರೀಬಹುದು. ನಿಮಗೆ ಡೌಟ್ಸ್ ಇದ್ರೆ ನೀವು ಒಂದ್ಸರಿ ಇದನ್ನ ಸಾಲ್ವ್ ಮಾಡ್ರಿ. ಈ ಡಿಟರ್ಮಿನೆಂಟ್ ಅನ್ನು ಸಾಲ್ವ್ ಮಾಡಿದ್ರೆ ಇದೇ ಸ್ಟೆಪ್ ಸಿಗ್ತದೆ ನಿಮಗೆ. ಅದೇ ರೀತಿ ಇಲ್ಲಿ ಕೂಡ ಇದೆಲ್ಲಾನು ನಾವು ಮರ್ಜ್ ಮಾಡಿ ಯಾವ ರೀತಿ ಬರೀಬಹುದು, ಈ ರೀತಿ ಡಿಟರ್ಮಿನೆಂಟ್ ಫಾರ್ಮ್ ಅಲ್ಲಿ ಬರೀಬಹುದು. ಇದನ್ನ ಬೇಕಾದ್ರೆ ವೆರಿಫೈ ಮಾಡುವಾಗಿದ್ರೆ ಇದನ್ನ ಡಿಟರ್ಮಿನೆಂಟ್ ಅನ್ನು ಸಾಲ್ವ್ ಮಾಡಿ. ಇಫ್ ಯು ಸಾಲ್ವ್ ದಿಸ್ ಒನ್ ಯು ವಿಲ್ ಗೆಟ್ ದಿಸ್ ಟರ್ಮ್. ಸೊ ದೇರ್ಫೋರ್ ಈ ಎಲ್ಲಾ ಟರ್ಮ್ ನಾನು ಈ ರೀತಿ ಬರೆದಿದ್ದೇನೆ. ಈ ಎಲ್ಲ ನಾನು ಸ್ಟೆಪ್ಸ್ ಅನ್ನು ಸೇರಿಸಿ ಮರ್ಜ್ ಮಾಡಿ ಈ ರೀತಿ ಬರೆದಿದ್ದೇನೆ. ಸೊ ದೇರ್ಫೋರ್ LHS is equals to RHS. Clear? And now we'll discuss next concept. Yes, my dear students, this is the one example I am going to solve. So in this example I am using the concept of this property. It's not I am not this property I am using. I am using some more properties whatever I discussed, that all concepts I am using here to solve this question. So you can observe here this, the question is given to you is show that the determinant given to you, we should show that this determinant value is equals to 0. Clear? So you can solve again by usual method, that is general method. How will you solve? We will put the sign plus minus plus, like that you can solve, but that is sometimes that may be complicated. Clear? So for such cases what I will do, I will use simple properties whatever we discussed up to here, so that you can easily prove that this value of determinant is equals to 0. To show that what I will do, my dear students, just only I discussed here it is. So we have, so or else given, you can write here it is given. So what they given to us, this is the one determinant they given to you. So that determinant I am writing here it is a b c, a plus, I will write here it is due to space I don't have space there, so I will write here it is given. So what is that? A plus 2x x, b plus 2y y, c plus 2z z. So this is the determinant they given to you. This determinant, by using this property, can I write like this? Please see here it is a b c. Here it is. Here what is the property says? The property says that in any given determinant, if any rows have sum of the rows or columns have sum of the two terms, that can be expressed as sum of the two determinants. Am I correct? That property, I mean the property number 5th I am using now. ABC write as it is. Now here it is sum of the two terms is there. That I write, split this one a b c I write, and next x y z. Clear? And next, my dear students, again here it is a b c. The first row elements are write as it is. Now here it is a b c, sum of the two terms here it is. So therefore a b c already I wrote here. Next I will write 2x 2y 2z. And next the third row as it is x y z x y z. Clear? So just what I did, the elements of this determinant are, here it is in the second row, the elements are sum of the two or more terms. So in this particular example, two terms are there. So therefore this determinant can be expressed as sum of the two determinants. That I did. Now my dear students, this is equals to, I will write here it is, this I will write, this is equals to here ABC I will write as it is. The elements of this determinant I will write as it is a b c x y z. And next plus, my dear students, again we discussed in the properties, in the previous videos I discussed in the properties. What is that? Here any row or any column, from the any row or any column I can take the constant term. Clear? So here 2 is here also present, here also 2 is present, here also 2 is present. So therefore in these, from this determinant I can take 2 outside. I think that is from the property number 4. I think that I discussed that is in the previous videos. What it says, in any determinant, if the any row or column, if it is possible to take the common, then we can take the common and we can write here it is. Clear? So the 2 is here, 2 is here, 2 is here. So therefore I can take the 2 common. So I'll take the 2 common outside. I'll write that one, and A, B, C. And next, my dear students, here 2 already taken outside. Remaining is X, Y, Z. X, Y, Z. And here it is the third row elements is X, Y, Z. And this is equals to this. I will write it as directly. I write it as 0 plus 2 into this value. This determinant value is also 0. Why it is so? Because in the property 3 I discussed that in the given determinant, if any two rows or any two columns are identical, then the value of the determinant is equals to 0. That I discussed. So therefore here the first row and second row are identical. So therefore the determinant value of this is equals to 0. And similarly next, in this determinant also second row and third row elements are identical. Or else the second row and third row elements are same. So therefore the determinant value of this is also equals to 0. So therefore here it is 0 plus 2 into 0 is 0. So what they asked in the question, they asked this value is equals to 0. We should show that. So therefore I considered this. I written the sum of the two determinants by this property, and after writing this, next here it is this determinant I wrote as it is, and next in the second case here I have taken 2 common from this determinant, that is outside I have taken, and here from here to here I wrote by the property number 4. Clear? I took the 2 outside, and after writing after this step, my distance, next the determinant value of this is equals to 0 because two elements are element first row and second row elements are identical. So therefore the determinant value is equals to 0. And similarly here also second row and third row elements are 0. Third row and second row elements are identical. So therefore this value is also 0. So therefore 0 plus 0 is equals to 0. So therefore the determinant of this is equals to 0. Clear? Only within the 3 steps you solve this one by using the properties. So normal also you can solve, but that will be lengthier and that is very complicated to solve. And even that may take the lots of time also. Clear? So therefore for this reason we should know the properties. Clear? And next, my dear students, the 6th property that we will discuss in the next video. Thank you.